Alright, now this is our 1D relative velocity review video. And we start with this idea that motion is relative. In this topic, we're not going to look at speed as how it is directly measured with measurement tools. Here we're looking at it measured from a frame of reference. It's all about the observing perspective, how motion can be relative, that your speed relative to another object can be different, basically. Not just how it's concretely measured with measuring tools. And so, we have this equation right here to determine the relative velocity of an object with respect to another. So this is a basic example where you're going to have, or the examples we're dealing with, have three objects. So here we're going to start with object A, object B, and object C. You're going to have three objects. You can label it however you want. A, B, C is for this example. And if you look at each of these, you have velocities with two letters as their subscript. So looking at VAC, what this stands for is the velocity of object A according to C. So it's the velocity of A from the perspective of C. And then if you look at the other two examples, VAB, velocity of object A according to B, and BC, velocity of object B according to C. Alright, now, there are other tips and tricks here. What if you get something like this? Velocity of CA. Same two letters, but does that mean it's the same as AC? No. These happen to be the same magnitude, however, but they're opposite in perspective, opposite in direction. So velocity of C according to A is not the same as velocity of A according to C. They're going to have the same number, same value, but they're going to be opposite directions because they're opposite perspectives. So if I were to attach numbers as examples, if I were to say that VAC is equal to 5 meters per second, then VCA is going to be negative 5 meters per second. That's going to be important for certain examples. Alright, now how do we set up these equations? Because you could have any other objects, any other things, and we need to know how to set it up. Now, I want you guys to look here. AC. These two are the ones you want. And if you look at the two that compose it together, A and C, the ones you want need to be on the outside, whereas the third object you're trying to cancel out have to be in the middle. So if, for example, we want to figure out what is the velocity of BC. So if you want to set up an equation for that, you need to have BC on the outside, whereas the third object, A, is going to be on the inside, so it cancels out. See how it goes? B and C are on the outside, but A is in the middle because it's being the third object canceled out. So that's how you set up these equations. And I'm going to go through the three sample problems that are in the packet, so if you just want to review them from scratch, pretend you never did that work, you can follow along right here. So here we have three objects: a train, the ground, and the businessman. So I'm going to put T for train, M for man, and G for ground. Alright? So the velocity of the train traveling 60 meters per second east with respect to the ground. So this is the velocity of the train with respect to the ground, and it's 60 meters per second going east. Whereas if you also have a businessman on the train running 5 meters per second to the west with respect to the train. So we have the velocity of the man with respect to the train. And it's going 5 meters per second, but it's going west, that's the opposite direction, we'll make it negative. Now for this problem we're looking for the velocity of the man with respect to the ground. And when we set it up, you might think in your head, oh, I know how to do this. I don't need the equations to help me solve for this. I can think this out logically. But there might be some people who might need the equations to help guide them. And eventually they might be able to think it out logically for themselves. So if you already know how to solve this logically, then hopefully it'll check out with the equation method. But right here, I'm going to show the equation method. So let's set this up. We're looking for m and g, so we need those two letters on the outside. T is our third letter, which is going to be canceled out in the middle. So VMT plus VTG. All right, notice how T is in the middle. That's our third perspective we're trying to cancel out. So do we have MT? That's negative 5 meters per second. And we have TG, that's 60 meters per second. And you should get 55 meters per second going east as your velocity for mg. If that's what you got logically, then you're probably on the right track for thinking this through. Alright, so here, now we have two buggy cars and you. That's our three objects. So buggy car A, with respect to you, I'm going to pretend that your object C equals you. So we have buggy car A traveling 45 centimeters east with respect to you, while another car B travels 30 centimeters west with respect to you. So B, according to you, is going west, so it's negative 30 centimeters per second. So we need to find buggy car A with respect to B. So we're looking for VAB. So C needs to be in the middle. VAC plus VCB. All right. Now careful here. We have AC. That's 45 centimeters per second. But we don't have CB. BC is different from CB. So remember this. BC does not equal VCB. What we're going to do instead is negate it. So if VBC is negative 30, that means VCB is positive 30. It's equal but opposite in direction. So this is going to be a positive 30 centimeters per second. So it's going to be 75 centimeters per second overall. So with respect to B, car A is moving 75 centimeters per second. It's going really fast. And here's our last example. Here you're riding in a bus moving slowly through heavy traffic at 2 meters per second. You hurry to the front of the bus at 4 meters per second relative to the bus. What is your speed relative to the street? So there's U. Let's put P for person. Let's put B for bus and S for street. So you're riding in a bus moving slowly through traffic. So this is the speed of the bus relative to the street. The bus is moving slow through traffic. According to the streets, 2 meters per second. You're going to the front of the bus at 4 meters per second relative to the bus. So that's the velocity of U relative to the bus, 4 meters per second. What is your speed relative to the street? Your speed. So that's P relative to the street. Okay, let's check. We have PB and we also have BS. So PS is 6 meters per second. So it looks like, according to people outside on the street, you're moving really fast. Even though you're physically moving 4 meters per second, from the outside perspective to the street, you're moving much faster, 6 meters per second. So it's all about perspective. It's not what you concretely measure with tools. So it's all about the perspective, the observing reference frame. All right? And so problems like this is what you'll encounter on the quiz. Shouldn't be too bad. If you also need additional help, feel free to come ask me. But I hope this video was helpful. Take care, guys.